This is Geometry, Unit 2, Lesson 4, Reviewing Basic Postulates. First of all, let's talk about what a postulate is. We talked about this a little bit in the last unit. A postulate, also called an axiom, is a statement, not a definition, that is accepted without proof. It's a statement that's made that is always true. It doesn't have to be proved. Everybody accepts it. Now, theorems are a little bit different. A theorem is a statement that has been proven using definitions, postulates, and previously proven theorems. When you have a theorem, you have proved that this statement that you're making is true based on stuff that you know. We'll be talking about theorems, more theorems later on when we get more into proofs, but for now, you just should know that there is a difference between postulates and theorems. Okay, so we did the basic postulates in the last unit. We talked about them, how we use them, but let's apply them to in a geometry situation. So, the basic postulates as they apply to geometric figures. The reflexive postulate, this is the weird one. The reflexive postulate says anything is congruent to itself. So, if you have segment AB, it should be congruent to segment AB. If you have a segment, it's congruent to the same segment. If you have angle C, it's going to be congruent to angle C. Any angle or segment is congruent to itself, or line, or whatever you happen to be working with. The transitive postulate. The transitive postulate, remember, says if two things are both equal to the same third thing, then they equal each other. So let's look at our diagram of our triangle over here. We have if AB is congruent to BC, and then we have BC is congruent to CA. Then, well, notice your hatch marks here. AB is congruent to BC, BC is congruent to CA. They have the same hatch marks every time because BC is the same as CA. So that means that they're both equal to BCA, so those two segments, AB and CA, must also be congruent. So AB is congruent to CA. So since this is congruent to this, and this is congruent to this, these two are congruent. That's the transitive postulate. Now, technically, again, we could probably use substitution for that, but we'll talk about that in a minute. Now, for angles, the same idea works for angles. Angle AEB. Angle AEB is this angle right here, is congruent to angle BEC. BEC, right there. Now, angle CED, CED, is also congruent to BEC. They're both congruent to the same angle. BEC here and BEC here. So that means that angle AEB is congruent to angle CED. All right, now you can even add numbers in here if you wanted to. Say AEB was 50, and then that means that BEC would also be 50. And then it says CED is equal to BEC, so CED would also be 50. So you can see AEB and CED are also congruent. So it applies to angles as well. So the transitive postulate applies to both segments and to angles. Now let's talk about the substitution postulate. The substitution postulate says equal quantities may be substituted for each other in any expression. So basically, if you have a quantity that you know is equal to something else, you can plug it in wherever you see it. So let's take a look at our picture here. We have the measure of angle AOB plus the measure of BOC is equal to 90 degrees. So here's AOB and here's BOC, and when you add them together, you get a 90-degree angle, like right there. And then we know that angle AOB is equal to angle COD. Well, look at this statement right here. There's AOB, and then we have AOB there as well. Well, what could we write instead of AOB here that's equal to AOB? Well, it's equal to COD. So we could rewrite that statement to say the measure of COD plus the measure of BOC is equal to 90. So if we took this COD, plugged it in where we saw AOB, we've rewritten the statement by substitution. And again, it works for numbers if you plug in numbers. So let's say that AOB is 30. Well, if AOB is 30, doesn't that make BOC 60? Yep. And if BOC is 60, and then we have AOB is equal to COD, AOB is 30, well, doesn't 60 plus 30 still equal 90 for BOC and COD? Yeah, it does. So you can see that the substitution postulate works. You can plug anything that's equal in for something else. Now, our last basic postulate is the partition postulate. The partition postulate says the whole equals the sum of its parts. So if I have my segment AD right here, what are the parts that AD make up? Well, it's actually made up of 3 separate segments. It is made up of AB plus BC plus CD. Those 3 segments, AB, BC, and CD, make up segment AD, because those are the wholes equal to the sum of its parts. And what about angles? If I look at angle AOC here, AOC, it's this angle right here. How is AOC made up? It's made up of 2 angles. It's made up of the measure of angle AOB, which is this angle here, plus the measure of angle BOC. The whole is equal to the sum of its parts. So that is a review of the basic postulates. So this should not be new stuff to you. We did it in the last unit. Be very, very careful. Make sure that you're paying attention to what is happening when you do these.